All right, so a bit of an introduction about myself. I'm a data engineer at Google, and I'm also a content creator on LinkedIn as well as YouTube. So feel free to follow me there for more useful things on data engineering or tech. I have over 3 years, 3.5 years of experience now as a data engineer. I started my journey at ZS as a data engineer, and I guess I can see the first question, that how can I apply for data engineer role at Google if currently I'm a BTSA at ZS. Well, this is exactly how I started. So uh, that has been my background, and I learned everything from ZS about data engineering, that what exactly is big data, what is Spark, right? That was like my first Google as soon as I joined uh, ZS, that what is exactly Spark. And then from there, I think I've come a long way forward in learning a lot of things, and then finally working at Google. So Akash, to your question, BTSA is a profile that's Business Technology Solutions Associate, and when I had joined ZS in 2019, it was called BTA, which was Business Technology Associate. So ultimately what you do is you work in a lot of projects where you deal with large amount of data, and your work is either client faced or internal, but you get to learn a lot of new technologies. And for me, it was like I was in big data pod. Even inside ZS, there's a team who works specifically on data engineering projects. So that's where I was right after college, and you don't have any say in that. As a fresher, you just get placed wherever there is a requirement, right? So luckily for me, I was in big data team, and if you get placed in the similar team, it would be definitely very easy for you. But regardless, this solution involves a lot of data engineering across GS, and after a couple of years, you can definitely try to apply at companies like Google, or even after a year, you can start applying at companies like Amazon, because just keep looking for any data engineering open jobs, and ZS has a good brand value when it comes to those companies as well. They know that we do deal with a lot of data. But yep, how much experience is required for the job is subjective. So sometimes at Google, mostly I've seen that they require 2 to 3 years of experience, but at Amazon, the mostly data engineering positions require 1 year of experience whenever they're hiring from off campus like this. All right, moving forward, let me mark this question as answered. Do Google recruiters take BTS a consideration for? Yes, they do. It's all about what your skills are. They don't really care what you are called in your previous company. All right, so now we are going to talk about all these things in the agenda. What is data engineering? What's the difference between data engineering, science versus analytics? How does typical career progression looks like? What are skills required, and what are different kind of profiles? And then ultimately looking at some of the salaries of data engineering. Now, when it comes to data engineering, I think Dr. Saurabh mentioned a lot of these things. That first of all, as data engineers, our job is to collect data, and this can be from various sources like instrumentation, some logging, some sensors, or even some external data sitting on an external database, something like a user data, and then we have to pull all of these things at a particular place. Uh, so we have to move that and store it in a reliable place. Let we have to move it and store it at a place where the data can be scaled, so there's no limitation on the amount of data that you store. So that's where you see you need to have good infrastructure, you need to have a reliable data flow, you need to have some set pipelines. You might need to transform your data, so that's where transform and load also comes into picture. And your data can be structured or unstructured. So that's about move and store. And then after that, you also do some cleaning. You find out if there were any data quality issues or anomalies in your data, and then you prepare your data. That means you join X table with Y table, and then maybe you apply some aggregation. So for example, you have a user table, you have you have an order ID table. So you join the two, and then you find out user level orders, that how many users are ordering XYZ items, right? So if you want that kind of analytics, it's our job as data engineers to prepare that data. So SQL, all these skills are very much required. And then after that, uh, if we go to the third level of the pyramid, analytics, metric segments, splitting into training, testing data, and training your models. So all these things would generally come into data science, um, data scientists' purview. So where machine learning engineers would, do some feature selection, and they would train the model, etc. And then they would finally do some A/B testing, do some validations, and then deploy it as well. So these two segments, it would fall into usually a machine learning engineer's purview, and then finally uh, AI or deep learning engineers would come into play as well. Now, it's not like because you're a data engineer you'll be working on these three things. It's possible that you can be working across the pyramid, depends on what your role is. um, and a lot of times in small startups the lines get blurred, and I think in the future also it will keep on getting blurred. So even my experience, if I tell you, after 1 or 1.5 years, I started getting a lot of projects that made me move into machine learning. So even though I'm technically a data engineer, I have trained a lot of models and I have deployed them. I have also done ML ops. So it's not like just because you're a data engineer, you don't deal with machine learning things. These are boundaries which are set by typical academic systems that you see. Like, for example, you have a lot of courses right now online available. So people usually don't tell you how to deploy a machine learning model in data engineering, but in real life, you may have to do it. But yes, it's not like this is expected out of you. Over the time you can grow into different kind of roles. Now these are the typical things that a data engineer does in like 70-80% of the cases. So just go through them and see if you like it, because as a fresher it's important to select a good career path. Now if you go into testing, if you go into development, if you go into data engineering, whatever domain that you go into, after you spend a couple of years in that, your next opportunity might be in that same domain as well. Because it's now, it's easy to change domain obviously in the career, but if you want to have a good trajectory of growth at least for the next 5 years, it's good if you decide on a particular domain and don't keep changing it at least for next 3 to 5 years, so that even if you change jobs or even if you get promoted, your skills, original skills, are valued, and you can get good salary hikes as well. So these are typical things that a data engineering does. Don't just jump into data engineering because you like numbers and you like talking about data. There are lots of small things that we need to consider as well. So we have to first of all acquire data sets that align with business need. This is one of the biggest headaches as a data engineer, because we usually have at the start of the project a scope setup that we want to create this XYZ dashboard, or we want to train this model. But us as data engineers, we have to look at whether even do we have the data available. For example, it's possible that your client asks that they want a daily level sales dashboard created, right? But now you don't even have the data at daily level, you have it at monthly level. So it's a headache, a very big headache to fill this gap of data. So data engineers are usually involved in this at the start of the project. Then develop algorithms to transform data into useful actionable information. I gave you an example of transformations. And build, test, maintain database pipeline architecture. So maintaining part is so much key, because see, there are two types of projects that you'll work in. The projects where you create something and you leave, right? But then there are projects when you create something and you also have to maintain it for a long term. You have to keep enhancing it, you have to keep including new data sources. So if you think that data engineering is only about creating fancy things, and then okay, I created something in 3-4 months and then moved on to something new and created something there, it's not like that. Most of the product based companies, you also have to maintain what is created, and then keep improving it. Collaborate with management to understand company objectives, and then create new data validation methods, and data analysis tools. So even at Google or even at ZS, we had created internal assets which are used for internal teams. Or if I'm creating something for X client, it's possible that it can be used for Y client, right? So it's good if I just create a reusable asset or just a tool that can be used across projects. So data engineers do this a lot as well. You also have to ensure compliance with data governance. So uh, for example, companies like Google, right? We uh, we use data a lot to improve our products. And a lot of people I know think that we know everything about everyone, what is going on, but it's not like that. Yes, we do have a lot of data available, but all of that data is anonymized. So for example, I can see that a person X has bought something, or a person X has clicked on this particular ad, right? Or these are the search results, but I cannot name that particular X person, or I cannot uh, I basically have no personal information related to that person X. All we have is, okay, person X is interested in this. They might also be interested in this. So these are data governance policies that a lot of companies have to comply with. You cannot use, just for example, your credit card information, your everything, personal information like your name, etc. Everything is anonymized. It's all like a black box. So you have to comply with all these policies as well. Also, European countries, etc., they have different policies, so you have to ensure that you comply with them as well. So typical data pipeline looks like this, where you have different data sources, you do some cleaning, processing, feature engineering, and then finally, most of the goal of data engineering projects is to enable dashboards, data exploration, or enable your data so that it can be processed by some machine learning algorithms. Uh, so this is how it looks like, that you have, first of all, on the left hand side, you have an operational data plane. So this is like a highly automated place where data automatically comes in and it gets ingested, it gets transformed, and it's responsibility of a data engineer to create this operational data plane and create the data pipeline. And then after the data is processed, it's thrown into analytical data plane, so where some of the data might be on data lake, some of data might be on warehouse. So lake is basically where your data is just staying there in whatever format that you want. There is no structure to it. But data warehouse is like, there is a lot of structure. Data is divided into database, schema, and tables. And it's a much more confined space with a lot of rules that you have to follow. So in analytical data planes, this is where business analysts, right side, and the data scientists usually come in. But the yellow part and the red part is something that data engineers have to design. Uh, so I love looking at this because this actually signifies a very good thing. I also included this in one of my videos. So you can see the term big data started becoming very popular after 2010. That's where 2000, around 2014, Spark was invented, and people started talking about big data a lot. That you know all those memories and execution, in memory processing, and all that. But you can see the word data engineering started picking up a lot later, like in 2019, right? So this is where people started realizing that it's not only because it's very important to hire data engineers. If you only hire data scientists and tell them that, okay, train machine learning models, do some fancy things, nowadays people assign machine learning to everything because it's a hot keyword, and AI. So a lot of people started doing that with their companies, and then found out that the output or accuracy of their models were not so great. That's because the data, underlying data, was not really prepared or cleaned, or even not at a level that was required. So that's where they started realizing that data engineering is so much more important after 2017. uh, that even you see that around every one data scientist needs 4 to 5 data engineers, and that's true. uh, but a lot of companies did not have that at a time, so then you can see the data engineering keyword started picking up a lot. So I'm going to go through some of the differences between a data engineer, analyst, and a data scientist. Data engineer we've already seen. Let's look at data analysts, right? So they deliver value by analyzing the data. So they come where on the analytical plane side, the blue component that we had, and they have good communication skills. They are business savvy, so they know more about business. They know more about metrics. They are like the functional team who knows what is the input of data, what should be the output of data, in a business standpoint, not in a very technical standpoint, right? So uh, these are the data analysts, but they are also very good at SQL visualizations, because that's where they come in and finally create value to the end user. So they are the ones very close to product owners or CEOs in any companies who want something, who want some analytics out of the data. For that, you have to be good at SQL, BI, Python, and R. Now, if you look at compare it with data engineering, that's pretty much the same. But there are a couple of things which are added here, which is cloud and distributed computing. So, for data engineers, the scale of data is very large. When it comes to data analysts, that scale has shortened down, and it's very manageable. So, they don't really need to learn distributed computing, and they also don't need to learn a lot about cloud. Now, if I run, let's say, 5 terabyte of if I have a 5 terabyte table, and if I want to join it with a 100 GB table, if I use my laptop to do it, it will take me ages, right? But if I use some cloud technology, distributed computing, let's say an example of an EMR on AWS, if I have a 100 node cluster setup or even 20 node cluster setup, it would take half an hour or maybe just 1 hour at max. So that's where distributed computing comes in, and data engineers, that's why have to be much more tech savvy compared to data analysts. Data scientists, they again solve business problems, but usually by statistics, mathematics, programming skills, and also a little bit of big data. So they also have to be good at SQL, Python, R, and cloud as well. So here is where you will, do some feature selection, train your model, and ML ops cycle will start, where you deploy something and you keep monitoring how that model is performing, etc. So before I go into this slide, it can be a little overwhelming. Let me go through some of the questions to see if I have already answered something, and if I haven't, I can start answering them. Best stack to master to get into DA Google as a fresher. Okay, I'll cover this in the upcoming slides. It's already there. Is open source projects helpful in this field? Okay, I'll cover this as well. As data analyst, is it mandatory to have ML's knowledge? No, not at all. You are not expected to have machine learning knowledge as a data analyst. Mostly, you are expected to have good BI skills, SQL, and good communication and business context. Not a lot. ML is not at all required. So I'm going to mark it answered. What is the difference between a data engineering and data science? Is it same? No, it's not. I hope I've already answered this until now, so I am going to mark it answered here. So data engineers is like a prerequisite, and data science is the ultimate goal of any company. They basically want to train models, they want to use machine learning to improve their products over time, right? But data engineers are the ones who create the underlying infrastructure and get the data. Your view on remote jobs? There are many available nowadays thanks to COVID. I mean, I shouldn't have said thanks to COVID, but at least because of COVID, because of remote work, a lot of remote jobs have started. So it's very easy to apply as well. So you can just go to LinkedIn and apply to any remote jobs. Mostly, if you're a fresher, you will not be hired for a remote job outside the country. But if you have a year or two of experience, then it's very easy for you to do this as well. So that way you can earn in dollars and spend in rupees. But there are lots of cons as well here. It's not just all good things. You have to manage your time zone, your work life balance might get impacted, you might have to work at night. So all those things are there. And also, because of remote jobs, companies locally have started to realize that they have to up their scales, right? If somebody is offering me 100K in living in India, if I work by working remotely, then companies have started realizing that, and they have started upscaling the upscaling the payment or upscaling the salaries of employees in India itself. I'm going to mark this as answered. I also have a good video on this topic on my channel. I've given the link in the chat if you want to check it out. I also had a similar remote job offer, and I keep receiving it on LinkedIn on multiple, like almost every month I get such remote jobs opportunities that I'm not currently engaging to. But yes, it's very common. What is the difference between a data analyst and data engineer? Okay, I think this is already answered. All right, let me move on. So this is basically a sample data pipeline that you have different data sources. I've used Azure Stack here. So ADLS is like, imagine Google Drive hosted on Azure that can scale up to unlimited terabytes, petabytes of data. So that's where most of data engineering projects, if it is hosted on Azure, that's where they store their data. If it's on GCP, the service is called GCS. If it's on AWS, it's called S3. Then we use compute like Databricks, which has Spark installed. It does in-memory processing. So here is where we clean our data, transform our data, and then we finally put it again on ADLS. After that, we now the Databricks part, the 1, 2, 3, 4 bubbles that you see, this is your operational data plane, and even the ninth one, because basically your orchestration is happening on Azure Data Factory that you see here. This is like, maybe you would have heard of Airflow, which is an open source tool. So orchestration is where you, now let's say you have created your pipeline, but now you want a place where you can trigger it, where you can run it, where you can monitor it, what is the state and all that. So that is something that you can do on Azure Data Factory. So and you store your configurations, etc., on a MySQL table as well. And here is where you use Python. So this is your orchestration platform. So 1, 2, 3, 4, and 9, these bubbles would come into the operational plane, and then fifth and sixth. So this is the final data lake where we are storing our data. So this is an analytical plane, and after our data is stored, we bring it into a more structured format, put it into a data warehouse. Now there are multiple options for this. This is called semantic layer, which is the final data warehouse in which your dashboards or your data science workloads are connected to. So you can host them on Snowflake, on Azure SQL or Databricks, etc. And here is where you can see, Tableau, Power BI, you're creating dashboards here, or maybe you're creating your analytics or data science workbench here. So your business analyst would work into this 6, 7 number bubble. Your data scientist would mostly work into 8 and 5, and sometimes also directly in 1 in case there is an issue in the data. And your data engineers would work on 1, 2, 3, 4, 5, 6, and 9. Also, a lot of times your continuous integration and continuous deployment. So this is where you keep your code, where you deploy your code. So you use different technologies. These are Azure specific technologies, but open source examples can be GitHub or Git pipelines, etc. This also comes under data engineers responsibility. So now you can understand these a lot of these technologies us data engineers have to take care of. That's why it's the most technical job profile out of the three. Now there are multiple career paths. A data engineer can stay into data engineering and become a senior staff or senior staff data engineer, and ultimately director or VP level is the final goal. And after that, another thing is that a lot of data engineers, after 1, 2, 3 positions, they jump into manager, becoming managers. And that is also an option. And some data engineers also pivot into being a data scientist. So as I said, a lot of my role uh, nowadays involves a lot of machine learning related work. So if somebody likes that, they can easily switch into being a data scientist and then go to that ladder, which is exactly same as the data engineering ladder. This is more like an individual contributor ladder, and this is like a management ladder. People can also be a data architect. So data architect is the one that creates the overall architecture, the one that you saw on the previous slide. And a lot of their job is to just design the pipeline, not really implement it. So that is also a career path, becoming a data architect. But for that, you have to be a little bit experienced. So it all starts with being a data engineer first. Tools and skills required to be a data engineer. So you have to be good at one of the programming language. These are common languages. You can choose any one of them. My personal favorite is Python because it's used a lot. It's used in software development, also in data engineering, and it has very wide number of job openings available right now. You also should learn common data pipeline tools. So these tools can include tools like Airflow. Azure Data Factory was one example, right? On AWS side, it can be Glue. So these are different tools. I'll cover how can you learn those tools in the upcoming slide. But yes, that is also a requirement. We have to also learn one of the cloud services: AWS, GCP, or Azure. These three are leaders. Now you can choose any one of them. I don't really like getting into cloud wars. uh, all three of them have their distinct feature sets. 80% of the services are same, but rest of 20% of the services, Azure is good in something, GCP is good in something, AWS is good in something, and there are also cons. So just pick anyone. It's not like you've worked into AWS then you cannot switch into GCP, because before I joined Google, I had not even opened a Google Cloud Console. I only had worked on AWS and Azure. Still, they hired me, and now all of my work is in Google Cloud. Then store and manage. You have these kind of S3. We already saw this like as a data lake option. Redshift is like a data warehouse. Hadoop is a place where you can store your data distributed in a distributed manner. For processing, it's good if you learn Spark. Forget about Hive, Hadoop for now. Yes, it's good to learn as a basic. It's a must learn. In fact, you cannot learn Spark before learning Hadoop. But in most of the job openings nowadays, people don't use Hadoop. Most of people are moving from Hadoop to Spark. So that's where your knowledge can be useful. That's not it. There are so many technologies. These are just, I'm pretty sure I'm missing a lot of them in this diagram as well. But uh, there are just so many technologies that we have to work on, right? So it's not like you can be a master of everything. It's just not possible. You learn a lot of things along the way. But at a high level, if I look at the technology stack, these are the high level things. Now, every tool that I've mentioned in this slide can be fitted into this particular categories, these categories on this slide. So for example, orchestration, this is where we talked about Airflow, Azure Data Factory, right? ETL, ELT. So these are the tools that does extract, transform, and load. So Spark, for example, the Spark is used for transforming data, right? So it can fall into this category. There are also some ETL tools where you don't have to do coding; you just do drag and drop. So they are like Matillion, Talend, all these kind of tools. They would also fall into this category. Then there are two types of data sources. One can be batch data sources and event, where your data source is live. Then your data is divided into two layer: raw layer and staging layer. So and then finally your core tables are created. So raw layer is a data lake, staging layer is generally a data lake, and core tables is generally your data warehouse where your final aggregates and analytics done. And then finally it's put into dashboards and ML. So in the previous diagram, a lot of these things are dashboards, a lot of these things are machine learning models, right? A lot of these things are data warehouses which can be fitted into this particular box, right? So what you have to do is, as a fresher, you have to at least pick one technology out of this. So for orchestration, pick one. For ETL or ELD, pick one, right? For everything, in this diagram, pick one technology from the category and then be good at it. That's all. That's all what requires to be a data engineer. Nobody is telling you to learn XYZ number of things, right? Nobody is telling you, okay, I know 4 orchestration tools, great, but what's the point of it, right? So just you have to be good at one thing, that's it. So for even for governance, security, you have so many things. So at the start, Dr. sort of mentioned that we also have to look at the security part. Who has access to what data? We have to also create the infrastructure, etc. So that would fall into this particular category. Lineage, we also have to create a lineage of where was my data, what 2 tables I joined, or what 4 tables I joined, what is my final data. So this lineage is shown into a particular graph, right? So there are lots of tools that show these kind of lineage, and metadata is like a catalog. Tools like Colibra, etc. would fall into this category. Data quality, there are so many tools for this, but as a concept you need to learn data quality and data observability. So now, for example, I'm ingesting and processing data this week, and then next data comes in, and then I'm doing the same thing again next week. I need a way to differentiate or look at my previous data outcomes in a log table, that okay, this was my this week's data, this is my last week's data, and this is success, this is failed, how many records failed, etc., etc. So this, all of these things come into observability. So this is the final stack that data engineers have to be good at. And I know it is getting a little confusing, but let me make it very simple now. So what is a must as a fresher or even as a data engineer, and what is optional? Okay. So must things are, you have to be good at, and by the way, also have a roadmap video where I'm explaining this exact same thing. So feel free to check it out. It also has some links where you can do some hands-on practice and learn things on the channel. So first is SQL. So SQL is key to becoming, go into any kind of data domain, right? So you have to be very good at it. The reason I've highlighted that in orange is that things I highlighted in orange are so much required that you have to be a pro at it. Python problem solving, yes, it's also required, but it's not like you have to be a pro at it. As I said, easy, medium questions are sufficient. You have to be a pro at data warehousing. So data warehousing is not just about creating tables and etc. It's about, let's say, creating a data model, right? So looking at a particular project, I should be able to define what are tables required, what should be the primary key, how these tables should interlink with each other. So these data modeling concepts, then high level, low level diagram, physical data plan of your data warehouse, all these things, all these concepts you need to be very good at. Spark is also something that every data engineer should be good at. And then one of the cloud platforms, AWS, GCP, Azure. Airflow is an orchestration tool. Kafka is like a queue where you can process live incoming data. There are some cloud specific substitutes for this, like AWS Kinesis, GCP PubSub, and I think Azure Event Bridge or something. So you can learn either of those, and then ultimately you have to be good at system design. This is not just for interviews, but it's also for your day-to-day job. So a lot of times you will be the one creating an end-to-end architecture, so you have to be good at understanding different cloud technologies and interlinking them together to create a final architecture. There are optional things mentioned in the right hand side. I'm not going to go through each and every one of them, but because these things are not really expected that you should be good at as a data engineer, but if you know them, then it's a good bonus. Right, so I hope I was able to answer a lot of questions which were based on skills. Now there are different data engineering profiles as well. So you can be an operational data engineer, one who maintains the pipeline. You can be a cloud data engineer who works on cloud technologies. Most of the data engineers nowadays are cloud data engineers, but still. uh, and then data architect, who does not create or maintain the pipeline but designs it. Data warehouse engineer, who only focuses on the warehouse component of data engineering and creates the data model and maintains the data warehouses like Snowflake, Redshift, etc. A data engineer who is good at ML. So this kind of data engineers are usually involved in a lot of feature selection, feature engineering processes, and also training machine learning models. uh, Distributed data engineer, most of data engineers are distributed because we usually work on Spark. And then real time data engineers, where uh, some types of data engineers usually work only on real time projects, or they are good at real time projects. Now your goal is not to be good at everything mentioned here. A lot of times you will play multiple hats. You will work on cloud, I will work on distributed data, and I will work on real time, right? So I'll be playing three different roles at the same time. Sometimes in a startup you can also work as a data architect. So you might be playing 3 4 roles at the same time. So it's possible that these DE profiles kind of correlate with each other. This is not a hard line that you are only a cloud data engineer or you are only a real-time data engineer, but your goal should be to be good at one thing. So if I tell you that what kind of data engineer you are, and you say cloud data engineer, that doesn't mean you don't know anything about real time data engineering. That means you're the best cloud data engineer. That's the skill that you like the most and you're good at the most. So pick one thing and master it, and be good and have some basic knowledge of rest of the things as well. That should be your ultimate goal. Now, salary of data engineers versus SWE. Now, I've taken it from sources like Ambition Box for India and Indeed for USA. Um, so you can see the salary is pretty much similar compared to a software engineer. Now, this comparison is kind of skewed, where uh, obviously we have a lot of software engineers in terms of number compared to data engineers, but this is the numbers. That's how it is right now. Like you have 10,000 software engineers, in against them you might have 1,000 data engineers, right? So in case in the future if we have 10,000 data engineers, then this salary would make more sense comparison. But on a high level, this is the average salary of data engineers in India is around 8.2 lakhs. Average Google salary in data engineer is around 46 lakhs. Now and the average salary in US is $135,000, which is very high, to be honest. Let me tell you that, because average salary US salary is around 70 to $78,000. So this is double that amount, at least 1.8x. So being a data engineer is definitely a good place to be in, no matter where you are. And and yes, as you can see, a lot of numbers compare well with Swiss. And data science salaries are also in the same categories. But data analyst, if you find, they would generally be on a little lower side. So in terms of salary, data scientists and data engineers are paid more than data analysts. So all this is good. Now, starting point as a fresher, right? So this is how it is in most of the cases, that right now tier 1 2 colleges, they do get direct data engineers placement in product companies like Fang or similar. But unfortunately this doesn't happen in tier 3 colleges. And for example, I graduated from Nirma University, which is a tier 3 college. But we also had Amazon, right? But Amazon was hiring at Swiss. They were not hiring for data engineers at freshers. And this is a hard reality, that these kind of companies they very rarely prefer freshers. So what is the starting point for you, right? For majority of us. So there are so many service based companies like Deloitte, KPMG, PwC, MU Sigma, ZS, and many more, many more. I'm definitely mentioning only 5% of what companies are there in India. So they hire for positions like business analyst or business associate, business technology analyst, technical analyst, data engineer, data scientist, or business operations analyst. So these are different positions. So don't think that just because your position is business technology analyst, you're not a data engineer. You are a data engineer if you're working on data and you're working on all the technologies that I just covered in this webinar, right? Even I was hired as a business technology analyst, as I said, at ZS, but my resume I showed that I'm a data engineer, because it's not that I'm lying on my resume, but this is exactly the job of a data engineer. So this is what I was showcasing. And also, after I got promoted at ZS, my role was moved from business analyst or senior business analyst to becoming a senior data engineer itself. Um, so a lot of the times this should be your starting point, and then gradually after a year or two you can move into companies that people glorify a lot, like Fang, for example, and for good reasons, obviously. But I think that should be your career path. Yes, there are folks, for example, at Google also, I've met couple of freshers. Like one of the fresher I knew, she was from PES University in Bangalore, which is obviously a good college, but she joined Google as a as a as an intern, and she must have applied through off campus. So keep a lookout. Talk to anybody who is working at Google or working at Amazon always. If that's your goal, right? Amazon, Google, whatever your goal is, or Apple or Microsoft, right? You can obviously apply at off campus internships and you can get selected no matter where you are from. Yes, from tier 1 2 colleges your filtering is faster, maybe in terms of your resume selection it's possible, but it's not a hard rule that you cannot get selected. There are low amount of such cases, but they are there. So now, coming to this, actually before coming into this, let me answer some of the questions that we have. Best stack to master, okay, I've already covered this. uh, there is no best stack. Whatever stack that you want to work on and you're working on, if that can be fitted into that block diagram, that's more than enough. Open source projects are helpful. So a lot of times in interviews you'll be asked that, okay, I created something using AWS, but now create the same system design using open source technologies. uh, Unfortunately, I have not come across any platforms where you can learn about these things directly. But if you but PG programs like Praxis business schools and all that, we would definitely cover they would definitely cover everything that you need to learn about, even the open source projects, etc.
I might be.
And is it possible to switch from core mechanic to data science roles? Yes, I have seen a lot of people from one of my friends was in chemical engineering and he was in ZS, and right now I think he moved to Gartner, which is a very reputed consulting firm, as a data engineer. So it's possible for core mechanics or any these kind of branches to go into data science roles, but your start will not directly be as a data scientist or a data engineer. Your job might be called like a business analyst or something. How to deal with scenario where companies require at least 2 years of experience in data engineering field? You can't really do anything about it, right? I mean, they require, then they require it, you have to wait it out. Um, but there are, as I said, a lot of companies which do not have this threshold. Try starting with that. And see, don't confuse that. Don't think that Google pays more or Amazon pays more than service based companies. It's not like that. It's depending on your skills. On an average, yes, product based companies pay more than service based companies, but there are so many people who earn more or equal to product based companies, even in service based companies. Like for me personally, it was very hard to for Google to match my salary. I had to do a lot of negotiations to even for them to match my, their first offer was actually below my current salary. So and they mentioned that your salary is already pretty high, what can we do about it, right? But then after some negotiations it went up. So there are so many service based companies that will give you good hikes. So don't think that this is your only final uh, goal. What is the difference between data engineers and DBA? Database administrators usually work only on databases and uh, roles, things like granting somebody access or making sure that policies are applied, governing them. Data engineers cover a lot of things. All right, so I guess I have answered a lot of questions. I cannot answer all of them. Maybe if I have time in the end, I will. Coming back to the PPT, so Praxis Business Schools, uh, so they host a good PGP in data engineering. So this is just numbers from the July 2022 batch, and highest hike over previous salary was 33%, which is like double amount of whatever they were earning. And average hike was 120%, which is super high. Even the median hike was 100%. So and you can see, look at the average and median compensation around 13 and highest 16 LPA. So Praxis Business School PG Data Engineering is a super good program, and you would learn everything from start to end, right? All the things that were covered in the uh, PPT and much more. You will just do a double click, triple click on all of those topics and come out a great data engineer on the other side.
Thanks so much, Yash. I'd like to highlight few things. Okay. One is the highest hike over previous 233%. So that is basically more than triple, right? So there was this candidate with a 4.5 lakhs of salary who got that 16 lakhs of a compensation, right? And the average hike, median hike was 100%, which means people could just double their salary on the way of this particular program. And the program is of a 9 months program. It's a 9 months weekend program, right? So classes typically happens on Saturdays and Sundays. So typically on alternate Saturdays is when the classes happen, and on the Sundays. And the way in which we structure the program, it actually covers all the things which Josh had said. One part is working with the traditional data, which means all your existing ERPs, DBMS, right? Your flat files, how to deal with that and get insight from it. That's our first part. The second part, what we do is we teach people that how to work with the big data stack, streaming data analytics, right? So all this Hadoop, your Kafka, Apache Airflow, and then your Apache Spark. So those kind of things are being covered in the term two. And the final term is where all these different cloud technologies, right? Typically, we focus on AWS and Azure. So that is being covered in details along with the Capstone project, which is supported by our industry partners. So the knowledge partners for this particular program are Genpact, Latentview, and Chubb. So he helps us with the live case studies, things which are right now hot in the market, and that those kind of a capstone project. Once people does that, they're through with that, they are ready to go and become productive from the day one. Right? That's what we do in this particular program. Sorry, Josh, for cutting you short, but yeah, I thought since you're talking about my program, I should just add few points. Please carry on.
Yeah, completely fine. And thanks for jumping in. You explained it much better than I could. All right. And here are the contact details. If you want to get in touch for this program, this is the email ID, mobile number, and the website where you can contact as well. And I guess one of the questions was that can we get a recording of this? I'm pretty sure it would be possible. Uh, and maybe Ayush can
Yeah.
tell
Sure.
that.
So everyone, you will be getting the recording. We will be going to mail you that. And yes, of course, just as I said, I have pasted the program details, the program video email in the chat itself. So if you are interested in that, you can come join the program, upskill yourselves over the weekends. It's a 9 month weekend only program. So you need not to quit your job or anything. And you can upskill quickly and have a robust career ahead. With that being said, thanks a lot, Josh, and thanks a lot, Dr. Saurav, for joining us. Everyone, we hope it was a great webinar for you. You got the foundations, you got to know about data engineering better than before. Now you have a clear head ahead, and we wish you best of luck. All right.
Thank you, everyone.
Best of
All
luck.
the best. All the best to
Thanks.
everyone.
Bye.
Keep shining. Yeah.